This lesson is focusing on developing mathematical models. So from our previous video, we looked at this example where we had shape numbers and number of counters. Notice that we have shape numbers on the top row, and on the bottom row we have number of counters. This is done deliberately. When you are looking for an algebraic relationship between two variables, which is shape number and number of counters, you are trying to find how the x value affects the y value. So we're going to introduce two new terms. These are the independent variable and the dependent variable. So in this example, the shape number is called the independent variable because it can be any number you want it to be. So then we have a look at our number of counters, and this one is going to be our dependent variable. And it's our dependent variable because the number of counters depends on the shape number. And it's always the variable being measured. So let's take that away. So just remember, this is the easiest way to remember it. The value of y depends on the value of x. Okay, so let's have a look at a few examples to try and wrap our heads around these two definitions. So example 1, we have some libraries charge late fees for every day your library book is overdue. The variables are number of days late and fee charged. So which one is our independent variable and which one is our dependent variable? So which one is any number you want it to be? Is it the number of days late? This one, number of days late? Or is it fee charged? The correct answer is number of days late. So that means our dependent variable would be fee charged because the value of y depends on the value of x. So the fee charged depends on the number of days late. So we're going to write that as a statement so that it might make a little bit more sense. So the fee charged, I'm going to do it in capitals, depends on the number of days late. Okay, so the fee charged, which is our dependent variable, depends on our independent variable, the number of days late. So let's have a look at one more example. So we have a car is traveling at 50 kilometers per hour. If the speed remains constant, the distance traveled depends on the time. So what is the independent variable? What is the dependent variable? Let's have a look at those two first. So just like we had our statement up here, the fee charged depends on the number of days late, we have a statement here. The distance traveled depends on the time. So that would make time our independent variable, therefore making the distance traveled our dependent variable. So let's have a look at C. How far would the car have traveled in 1, 2, and 3 hours? So we're going to put this into a table like we did with our shape numbers. Okay, so our x value is always our independent variable. So in this case, it's time. And I'll write a little x here so you don't remember. Okay, and our dependent variable is going to be distance traveled. And that's going to be y. Okay, so we want to know how far would the car have traveled in 1 hour, 2 hours, and 3 hours. So if you are traveling at 50 kilometers per hour, that means that you are traveling 50 kilometers in 1 hour. So I'm just going to write my units here as well. So time is going to be in hours and distance is going to be in kilometers. Okay, so for 1 hour, we're doing 50 kilometers. So what did we do to x to get to y? What did we multiply it by? We multiplied it by 50. So if we are going to be doing 50 kilometers per hour, but we're going to be traveling for 2 hours, the distance we would have traveled would be 100 kilometers. If we're traveling for 3 hours, we're going to be doing 150 kilometers. So we need to write this as a rule. So we want to know our distance, which is y. And we know that y is equal to 50 multiplied by our time which is x. So having a look at D, we have how far would the car have traveled in 13 hours. So let's write down our rule. Y is equal to 50x. And what are we given from the question? How far will the car have traveled in 13 hours? So we know that this is a time and time is x. So we're going to let x equal 13. So substituting that in, we have y is equal to 50 times 13. Put that into your calculator and you should get 650 kilometers. So therefore, the car will travel 650 kilometers in 13 hours. Thank you for watching.